Namaste, welcome to Pythagoras Academy. This is Vikram Dachepally. In this video, I'm going to derive work energy theorem, which is otherwise called as work kinetic energy theorem. It states that work done by all external forces acting on a system is equal to the change in its kinetic energy. Point number one, the very expression or the definition of kinetic energy comes from this particular theorem. Point number two, work is one of the modes of transfer of energy. There are different modes of transfer of energy when the system is interacting with the environment in which it is placed. Heat is a mode of transfer of energy, electromagnetic radiation, or mechanical waves. For example, sound. So if you make a sound, there is definitely transfer of energy from the system. Electrical energy transfer. You can get the electrical energy by plugging into the electric socket, and the fan runs on it. If you take the fan as a system, the system is gaining electrical energy and it converts into the rotational mechanical energy. So out of various modes of transfer of energy, mechanical work is one of the forms or one of the modes of transfer of energy. So work energy theorem is limited to a few cases. It is not a generic expression that you can use it anywhere. So it is a limited thing where you are only talking about the work mode of transfer of energy. So this is a basic introduction of a non-isolated system. So there is a system and it is interacting with the surrounding. So the meaning of interacting with the surrounding is it is subjected to external forces from the surrounding. So take a system of mass m. Consider several forces acting on the system, F1, F2, F3, so and so on up to Fn, all external forces acting on the system. So there is net external force which causes acceleration. Let me say initially it has got some speed v1. Due to the acceleration, after some time the position of the system is changed and it has got the velocity of v2. Velocity has changed from v1 to v2 due to acceleration. So I am trying to find what is the work done by all these external forces. Consider a very small displacement dr bar, infinitesimally small. So for that small displacement, dw1, work done by the first force is f1 bar dot dr bar. Work done by the second force is f2 bar dot dr bar. But the third force is this, and similarly so and so on. Work done by the nth force is fn bar dot dr bar. This is the work done for very small displacement. If I have to find the total work done by all forces, it is sigma dw1, which is sigma f1 bar dot dr bar. That is f1 bar dot dr bar plus f2 bar dot dr bar, so and so on up to fn bar dot dr bar. Simplifying this, I would get f1 bar plus f2, so and so on up to fn dot dr bar, which is the net force acting on the system, that is f net bar into dr bar. By Newton's second law, net external force acting on the system is mass into acceleration. So I would write f net as m into a bar dot dr bar, and here I'll slightly manipulate this equation. I'll write a bar as dv bar by dt and further dv bar dot dr bar by dt. So work done by all forces acting on the system, small work done, infinitesimally small work done, is m into dv bar dot dr bar by dt. So that is equal to m into v bar dot dv bar. So we have dv and dr bar by dt, that is rate of change of displacement, which is velocity. Now what is v bar dot dv bar? V bar is velocity, dv bar is a small change in velocity vector. So it is small change in velocity's magnitude and direction as well. So the angle between v bar and dv bar is very, very small, say d theta. So if you further simplify this, it becomes v into dv, cos of d theta, very small angle, very small change in direction, which is tending to 1. So I can express dw all as m into v into dv. Now integrating on both sides, so I'm integrating on the LHS, that is integral 0 to w all dw all, that is equal to integral v1 to v2. Now the RHS is a function of the speed. So initial speed is v1, final speed is v2. Solving this, I get m into v square by 2, applying the limits, m into v2 square by 2 minus v1 square by 2. And solving this, I get work done by all forces acting on the system is half mv2 square minus half mv1 square. This expression half mv2 square is telling us that this is a form of energy. So all the work done by external forces has given some amount of energy to the system. So if external forces are doing work on the system will either gain energy from the environment, or the system can lose an energy to the environment. So half mv square or half mv2 square is the energy of the system when its speed is v2, and half mv1 square is the energy of the system when its speed is v1. Because LHS is work done, so there is a mode of energy transfer. So there's kind of energy transfer to the system, and that energy transferred is given in the RHS in the format of half mv2 square minus half mv1 square. So half mv square is nothing but energy, a kind of energy, a form of energy. And this energy arises because of the speed, because the only variable in this is speed. M is constant, half is constant. So we are defining this form of energy as kinetic energy, because this is energy possessed by system due to its motion or speed. So we are naming it as kinetic energy. So half mv2 square is k2, final kinetic energy, minus half mv1 square is initial kinetic energy. So that is k2 minus k1. Work done by all forces acting on the system is delta k, change in kinetic energy. This is work energy theorem. If work done by all the forces is positive, then delta k is positive. It means the system is gaining energy from the environment, from the surroundings, and that energy gained is appearing as kinetic energy. If work done by all the external forces is negative, the system is losing energy to the surroundings. That is the meaning of this particular equation. Yeah, as I said, this is very limited format of energy conservation, because we are in this case we are only considering the mechanical work mode of energy transfer. In any practical case, there can be several modes of energy transfer happening at once. So we need a more generic equation than this when we are dealing with that kind of cases. But as far as mechanics is concerned, yeah, work done by all the external forces is equal to change in kinetic energy. A very important noteworthy point is kinetic energy is nothing but the energy formed due to motion of a body is defined as kinetic energy, that is half mv square. That's all. If you have any questions or queries or suggestions, you can always use the comment section to interact with me. I'll be more than happy to respond and receive your feedback. This is Vikram Dachepally signing off. Namaste.